Okay, let's do some calculus. Integration. So remember, if you see this symbol here without any numbers on it, this symbol without any numbers on it, that means find the general antiderivative. Think plus c. Your function should be a function of the same variable that you're given. And if you see these numbers here, your answer should be a value. Could be positive, could be negative. All right, let's do some. This first one, if I see this, I say, how am I going to integrate that? You should be thinking u-substitution somehow. And a lot of times for u-substitution, our u was the input of a composite function. But sometimes u could just be our denominator. All right, if we're dealing with a natural log function. All right, so here's the process for number one. If that's what I'm going to, and again, sometimes we don't always pick the right thing for u. But the process would go like this. Take derivative. And then solve for the differential. And then substitute, right? So you're doing two substitutions here. You're substituting out x, hopefully, and dx as well. So I let u be my denominator. So right now I got x plus 1 over u times dx, which is this thing, du over 4x plus 4. Okay, now what I need, if I'm going to substitute to u, I need my x's to go away. Right? A lot of times when we do these u substitutions, it works out nice right away. We can cancel some stuff out, and I got just function of u to deal with. In this case, I'm almost there, but I just got to be able to see that one of these is a multiple of the other. Right? So that is, if I did one extra step, sorry, that's x plus 1. If I factor out a 4, then I get the cancellation that I need. Okay, so now, so that's a 1 over 4. I usually bring out the constant outside the integral, and then I'm just dealing with 1 over u du. Right, and this is the whole purpose of u substitution. I start with a complicated function that I need to integrate, and I end up with an easy one, right? One that we know how to deal with. And then I do my back substitution, and I'll be done. U was 2x squared plus 4x. Okay, let's try another one, an easier one. I don't need u substitution. Hopefully you can recognize that there's no composite function, there's no rational function, so I can just integrate by using my power rule, x to the 4th over 4 minus 4, constant multiple comes along, and then x cubed over 3 plus 4x, and I'll use this notation as I go from 0 to 2. That means I plug in 2 to the 4th, call that a 4 over 4, minus 4, plug in 2 cubed over 3, plus 4 times 2. That's when I plug in the upper bound, minus, and I'm going to plug in the lower bound of 0. Now, you might recognize that this is just going to be 0, but I just like to do that just to remind myself it's not always going to be, if this is 0, this isn't always going to be 0. Think about if it's an exponential, e to the 0 isn't 0. Cosine of 0 isn't 0. But in this case with this polynomial, if I plug in 0, that's 0, that's 0, that's 0, so I just get 0. So I just need to evaluate the upper bound to get my solution here. 2 to the 4th is 16 over 4 minus 2 to the 3rd is 8. 16 over 3, and then 4 times 2 is 8. Okay, think I did that right. That looks good. 8, no. 8 times 4 is not 16. 8 times 4 is 32. Okay, and then I'll go to my calculator for this. Well, wait, that's 4 plus 8 is 12. 12 minus 32 thirds equals over 3 times 3. That would be 36 over 3 minus 32 over 3, and I end up with 4/3. Okay, moving right along. More integrals to deal with. I have, let's do number 4 first. This one's going to be easy. What's the integral of e to the x is e to the x. So what's the integral of e to the negative x? Well, if I guess e to the negative x, remember, you can always check it by taking the derivative of that. The derivative of e to the negative x is not e to the negative x. You'd have to do the chain rule and you'd get another negative there. So we could probably figure out that should work out. If I differentiate that, I get negative e to the negative x times the derivative of negative x, which is -1, and I'd end up with that. You could do u-substitution, but I don't think we need it because we can kind of figure it out without the u. We could let u be negative x and do the same process we did in the first one and still end up with the same result. And the derivative of the tangent function is secant squared. So the antiderivative of secant squared is tangent. Done. Okay. Now let's tackle this one. I got 5x squared and I got the square root of x cubed plus 8. So what I have to do is, this should be a pretty straightforward u-substitution. Typically we let u be the input function. So u is going to be the input function, which is x cubed plus 8, which means du is 3x squared dx, which means dx is du over 3x squared. Now, I have a definite integral u-substitution, so I have to do some more. If I'm changing, these are x values. 1 and 2 are x values. So that means when x is 1, u isn't necessarily 1, right? U is going to be, in fact, 1 cubed plus 8, which is 9. And when x is 2, u is going to be, I'd plug in 2 right here, right? Plug in 2 here. 2 cubed is 8, plus 8 is 16. So when I do my substitution, not only do I have to sub out x and dx, but also these x values, right? Because I'm changing everything to u. So here's what this now looks like. I am going from 9 to 16. 5x squared times the square root of u times dx, which is du over 3x squared, and then I can kill my x. That says 3x squared. There's my typo. That should be a 5x squared. Cancel and cancel, and then I end up with the following. Now I got everything to u, so that's good. So I'm going from 9 to 16. I got a 5/3 that I'll factor out, and I have a u to the 1/2 du, which is equal to u to the 3/2. If I anti-differentiate this, u to the 3/2 divided by 3/2 or times 2/3 times my 5/3. And I got to evaluate that thing from 9 to 16. And that's going to be 10/9 is my fraction. And then I can just worry about plugging in 16 and 9 to that thing. So it's 16 to the 3/2 minus 9 to the 3/2. Okay, almost done. 10/9, and I have, remember, when I raise something to the 3, you can use your calculator, but the raising something to the 3/2 is like taking the square root of it and then cubing it, right? So the square root of 16 is 4. 4 cubed is 64. Same thing here, raising something to the 3/2, square root 9, you get 3. And raise 3 to the 3rd, you get 27. So I'm looking at 64 minus 27, which is 37 times 10/9 times, so this would be 10/9, and here I get 37, and then that should be 370 over 9.